All right, so we're working on using integration by parts more than once, and sometimes you do it cyclically, meaning you do integration by parts and then you get back the original integral you started with. And that seems like bad news, but it actually is good news because you can usually then solve for the original integral. And so one example that some people are having a hard time with is sine of 2x cosine of 3x dx. And I'm writing the parentheses this time just to be clear where the arguments are, but I'm going to leave them out later because it just is a lot of writing. So it doesn't actually matter here which piece you choose for u and which piece you choose for dv, as long as you include the whole integrand. So du is a derivative, so I'm going to multiply 2 cosine 2x dx. V is an antiderivative, so it becomes sine of 3x, and I'm going to divide by 3. So now my original integral becomes u v minus integral of v du. I think I missed a 2 when I wrote this. It's cosine of 2x. Great. Okay. Now the new integral doesn't match the old integral. I want there to be a sine of 2x and a cosine of 3x. And so what I'm going to do is I'm going to choose the same function piece for my u and my dv. I'm going to choose the cosine of 2x for my u, and I'm going to choose, so that would mean du is negative 2 sine of 2x dx. And I'm going to choose for dv the sine of 3x dx. The reason I'm choosing those is because I want to keep that inside piece matching. I chose the 3x function for dv initially, and I'll choose it again here. So the antiderivative of sine is negative cosine, and this one's divided by 3. You'll notice I didn't do the 2/3, the over 3, and the 2 here. I'm just going to bring that in front of the integral there. Okay? So now my original integral can be written as this. The first chunk, I'm just copying and pasting sine of 2x, sine of 3x divided by 3, or I could just write 1/3 in front of it. Then the integral had a 2/3 that I pulled out, and now I'm doing my new u v, so that's minus 1/3 cosine 2x cosine 3x minus the integral of v, which is negative cosine of 3x over 3, or I could have written it 1/3, du, which is negative, let me clear that out. Du is my last piece that I need, negative 2 sine x dx. So this is times negative 2 sine 2x dx. Okay. So now we're going to do some distributing. It gets a little tricky to keep track of everything. I see a double negative inside the integral. And then I also see a negative 2/3 distributed like that. So my original integral is 1/3 sine 2x sine 3x. Then double negative makes positive 2/9 cosine 2x cosine 3x. Then plus the integral here, 2/3 times all this junk here. Cosine 3x over 3 times 2 sine 2x dx. So what you can notice is that the original integral shows up here, but there's an extra divided by 3 and an extra times 2. So I'm going to factor those pieces out just like before. So 2 here, 3 here, and then I'm noticing that's the original integral. So just to save myself a lot of writing, I'm going to say I equals all of this stuff plus 4/9 of I. So if we subtract 4/9 of I, we have 5/9 I equals all of that stuff there. And then if I multiply by 9/5, I get my answer. So I equals 9/5 times, I'm going to move my face out of the way, times all of this stuff that I had been just using the quote marks for. So 9/5 times all this stuff. And believe it or not, if you take the derivative of this wonderful expression here, and you use the product rule, and you cancel all your stuff out, this will get back to the original integral. And you can see how that works a little bit if you start looking at some of the f prime g's and f g primes. So if you do f prime g, that's going to be a cosine times the sine of 3x, and it's going to have a 2 on it. And if you do an fg prime, it's going to be a sine times a cosine of 3x, and it's going to get rid of the 1/3. And as you go through each of those pieces there, you'll see that they sort of telescope out, and one piece cancels out the other. So let me know if you have any more questions. Happy to explain anything that was confusing.